Hello, 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 and welcome to problem set P2.1 video key. What could be more exciting than that? Let's just get right to it, shall we? Number one, above all else, what is needed in order to graph a line? Well, to graph a line, you gotta have 2 points. Gotta have 2 points. Any 2 points will do, because once you have 2 points, any 2 points, if this is a point on a line and this is a point on a line, then I simply can connect those 2 points with a line. So as long as I have 2 points, I can draw a line. Okay, we're going to graph y equals 3x plus 2 on the same coordinate grid as this graph as well. And I'm going to graph them in 2 different ways to illustrate 2 different ways to graph. One way, you should recognize this as being y equals mx plus b. So our slope is 3, and our y-intercept is 0, 2. So 0, 2 is the y-intercept, so that's a point on the graph. And then 3, or 3 over 1, is our slope. Okay, so on this graph over here, color code this for you. This will be the blue one. We can put the point 0, 2 on there. Make sure you write your points correctly. 0, 2 goes 0 left and right, and then up 2. And then our slope is 3 over 1, which means we can go from this point and go up 3, 1, 2, 3, and over 1, and create a second point. As soon as we have a second point, we can draw a line. But if you wanted to, you could go up 3 over 1 again and get another point. 1, 2, 3. Or you could go down 3, 1, 2, 3, and this way 1. As long as you have a positive sloping line, it doesn't matter. And so our line looks something like that. Okay, so that's y equals 3x plus 2. I'll label it on here. Okay, let's do a green graph this time. So for this one now, this one's a little different because it's not written in what is called slope-intercept form. So you could either write it in slope-intercept form, but I'm going to show you a different way. Let's find 2 points. So you can pick any number you want for x and then solve for y. So if you pick anything for x, I'm going to let x equal 0. So I choose x to be 0. And that will get us 4 times 0 plus 9y equals 18, which is just 9y equals 18, which is y equals 2 when you solve that. But remember, I chose x to equal 0. So this gives us a point 0, 2. Like that. And then let's do the same thing. Now I'm gonna let y equal 0. Again, I'm just choosing these numbers, but I'm choosing 0 because those are the easiest things. You can choose any 2 numbers for x and solve for your y's, any 2 numbers for y's and solve for your x's to get you 2 points. Once you know 2 points, you can just plot it. But if y equals 0, then we get 4x equals 18. Divide both sides by 4 to get x equals 18 over 4, which is the same as 4.5. Okay, so now we have the points 4.5, comma 0. So let's show this graph in green. We have 0, 2, which is that same point, and then 4.5, 0. So just estimate where 4.5 is, and then draw a line connecting those 2 points. And that is your other line. Okay. Now, what do these graphs have in common? Well, they have the y-intercept. They have the same y-intercept. What do we call the y-intercept? We usually call it b, like in y equals mx plus b. Okay, so when you have something written in this form, you know your y-intercept right away. It's just that b value. It's a point, 0, whatever the b value is. How do you find this if you're only given the function and not the graph? So how do you find a y-intercept? Well, every y-intercept in the world occurs when x equals 0. Plug in 0 for x and find y. And that will give you the coordinates of your y-intercept, which is exactly what we actually did right here in red. I chose x to be 0, and I found a coordinate right there, which was the y-intercept. What's a similar point we can find? Well, we can find the x-intercept. And we can find the x-intercept by letting y be 0. So plug in 0 for y and find x. And that'll show us where the graph crosses the x-axis, which is often quite useful. Okay, the most common form of a line that we study is the slope-intercept form, y equals mx plus b. It's called slope-intercept because here is your slope and here is your y-intercept. How to use this form to help you graph? Well, that's what I already did on 2a. So I'm just going to say C number 2a, because that's what I did. What if a function is not written in this form? Well, if it's not written in this form, we can get it in this form. So if a function is not written in this form, we can rewrite it in slope-intercept form. Or, as we did above, find 2 points. Okay, so I think I'm going to do this one both ways again. I need a coordinate grid here. All right, so I'm going to put these graphs over here where they fit a little better. All right, so first we're going to graph y equals negative 3x, or negative 3/5 x plus 7. So that might look complicated, but start at your y-intercept, 0, 7, which is right there, and then use your slope. So it's negative, so we go down 3, 1, 2, 3, and then over 5. So we're down 1, 2, 3, 1, 2, 3, 4, 5, right there. And once you have 2 points, you can sketch the graph just by connecting the 2 points, like so. All right, now let's graph this one. So again, to graph this one, I think I'm going to, let's use purple. I'm going to find 2 points. So you could solve this for y and do it exactly like we just did the last one. But I'm going to let x equal 0. So when x equals 0, we have negative 3y equal to 15, because this is just negative 9 times 0, which will be 0. So it kind of just goes away. And we get y equals negative 5. So we have the point 0, negative 5. Then we have when y equals 0. Again, you can choose any number for either variable. It's just 0 is the easiest in my mind. So when y equals 0, this cancels out. It's going to be negative 3 times 0, which is 0. And you get negative 9x equals 15. Divide both sides by negative 9, and you get x equals 15 over negative 9, which if you reduce it is going to be negative 5/3. So we're going to have to estimate that one. But we do have the point negative 5/3, 0. So we're going to have to estimate that on the graph, though, because it's not a whole number. Okay, so let's come over here and graph this now in purple using 0, negative 5, which is right here, and a slope of negative 5/3. Or sorry, not a slope of negative 5/3, a point negative 5/3, 0. So negative 5/3 is 1 2/3, so it would be about right here, and then 0. And so that graph looks something like this. And there you have it. All right. Number 4, the standard form of a line is written like this. It's just where x and y are on the same side. A, B, and C just are numbers. So like, here's an example of standard form. 6x, so like A would be 6. B here is negative 12. C here is 48. But it doesn't really matter. We're not going to refer to A, B, and C very much. But just standard form is x and y are on the same side of the equal sign, like this problem. Okay? So we're going to graph this by finding the x and y intercepts. That's what we've already done twice already. But when it's in standard form, it's pretty easy to find the x and y intercepts. So when x equals 0, we have negative 12y equals 48. Divide by negative 12 and get y equals negative 4. So now we have the point 0, negative 4. And then we can do when y equals 0, we have 6x equals 48. So x equals 8, giving us the point 8, 0. Plot those 2 points. So we have 0, negative 4, which is right here. And we have 8, 0, which is out here. And you just, again, draw a line between, or going through those 2 points. And if you missed, that's another reason notability is great. And there you go. All right, another form of a line is point slope. So we were doing slope intercept in number 3, and then we did standard form in number 4. There's another form called point slope, which you need a point and a slope. So not clever names, as I may have mentioned. A point and a slope are the 2 things we need. Now the equation for point slope form is this. So here's what it looks like, where x1 is just the x value of the point that you have, y1, so x1 is the x value, y1 is just the y value of the point you have, and then m is your slope. So how do you find the slope between 2 points? If you're given 2 points, hopefully you know that m equals y2 minus y1 over x2 minus x1. So that's the formula for slope. And then part CI right here says, do you see a relationship between your answer to 5C and the formula from 5B? So this orange thing here and that green thing, you might recognize that those look awfully similar. And I'm going to show you how you actually get one from the other. So if we start with m equals y2 minus y1 over x2 minus x1, we can manipulate this and solve it. We can get rid of the fraction by multiplying by x2 minus x1. Now this is kind of a weird step for some of you, I'm sure, because you've never really done this before. But it works, and when I do that, the x2 minus x1 cancels on this side, leaving us with x2 minus x1 times m equals y2 minus y1. And that's actually exactly the same as this. So the point slope form of a line, this thing written right here, just comes from this formula. It's just that formula rewritten. And I know you've seen that formula before, and you've probably used it 100 times. All right, so we're going to sketch a graph of this. So in this equation, we have a point and a slope. Now notice how the equation right here, so I'm going to rewrite point slope form. So we have y minus y1 equals m times x minus x1. So if we line that up, you can see what's what, but notice how there's a minus sign already here. So that means the y1 value is actually 5, and the x1 value has to be negative 4 because this is a plus sign, which means there had to be a second negative right there. That's where people tend to make mistakes if they make mistakes on this. So y1 is actually equal to 5, x1 is equal to negative 4, and m is equal to 2. So we have a slope of 2 and a point, negative 4, 5. Okay, so now we can graph that. I already have a grid over here. So we have the point negative 4, 5, which is going to be right here. And we have a slope of 2, which means rise 2, run 1. So up 2 over 1. And that's all you need is 2 points, as we said at the very beginning of this problem set. Draw your line through those 2 points, and you're done. That is a sketch of that line. Okay, number 7, a horizontal line. So let's draw a horizontal line on here, anywhere we want. I'm going to put it like right on one of the lines, though, so we can talk about the number that it is. All right, so we have, here's a horizontal line. Now, for this horizontal line, our y value is always 4. So our equation is just y equals 4. Because it doesn't matter what x is. Pick an x value, it doesn't matter. Every single x value in the world has a y value of 4. So that's our equation. Okay, let's draw a vertical line on this one. Here we go, here's a vertical line. And what never changes here? Our x value never changes. Our x value never changes. So that means our equation then is x equals, and then whatever x is always equal to. On this line right here, x is -5, x is -5 here, x is -5 here, x is -5 here. Y changes, but no matter what y is, x is always equal to -5. So it has no, the y value has no effect. All right, now there are 4 different types of slope. We're going to list them here. We have positive slope, negative slope. So positive, negative, no slope or zero slope. Let's say it's a slope of 0. And undefined. Okay, so this is a slope of 0. For a horizontal line, and this is an undefined slope for a vertical line. So that's just something you need to know. How can you tell by looking at an equation of a line what kind of slope the line has? Well, if it's in y equals mx plus b form, so if it's in that form, then this is your slope. So if that number is positive, then it's a positive slope. If it's negative, it's a negative slope. Or if you have a y equals equation, like y equals a number, then it's a slope of 0, because that means it's a horizontal line. If your equation is y equals any number, then the slope is 0, because it's a horizontal line. And if your equation is x equals any number, then the slope is undefined. Then the slope is undefined, because it's a vertical line. All right. So 4 different kinds of slope. Okay, and then we have a little bit of a word problem here where a line kind of makes sense. The school band is selling sweatshirts and t-shirts to raise money. The goal is to raise $1,200. Sweatshirts sell for a profit of $2.50 each and t-shirts for $1.50 each. Create a graph to represent this situation on graph paper. Identify the x and y intercepts and describe what they mean in terms of the story. All right, so first, what we know is they want to raise a certain amount of money, so I'm just going to call that R or maybe P for profit. So P equals profit. S is number of sweatshirts sold. And T is number of t-shirts sold. So then, I'm going to erase this. I don't think we need P equals profit. So what we have is we want to raise $1,200. So we want to sell a certain number of t-shirts, and we're always going to make $2.50 on those. Or sorry, that was sweatshirts. So you have $2.50. times the number of sweatshirts plus $1.50 times the number of t-shirts sold, and we want that to equal $1,200. Okay, so we can graph this. Let's see, let me copy another grid here. And I think the easiest way to graph this, oh, it copied over. I didn't think it was going to copy what I wrote. The easiest way to graph this is to find the intercepts. So when s equals 0, we have 150t equals 1,200. So just divide 1,200 by $1.50, which you can use a calculator for this, of course. So 1,200 divided by $1.50 is 800. So you get t equals 800. And then we can do when t equals 0, and that's 250s equals 1,200. So divide both sides by 250, and you get 480. So s equals 480. And both of these answers for the x and y intercepts in terms of the story are how many of each you would have to sell if you sold none of the other. Because see how we plugged in 0 for both of those? So if we sold 0 sweatshirts, we need to sell 800 t-shirts to raise $1,200. Okay, so the blue means this means we need to sell 800 t-shirts if we sell no sweatshirts. To raise $1,200. And then the pink is a similar thing, except it means we need to sell 480 sweatshirts if we sell no t-shirts. In order to raise $1,200. So we need to sell 480 sweatshirts if we sell no t-shirts to raise $1,200. Okay, so hopefully that makes sense to you. Let me change the color of this one. Okay, good enough. And then we were actually supposed to graph this. So I'm going to use those 2 points. Now this grid is no good. I'm going to ignore those values because I had to graph 0, 800. So it doesn't matter which one you call S and which one you call T. I'm going to call this the S axis. This is the T axis. So when S is 0, T is 800. So let's say these count as hundreds. So you get 0, 800 right there. And then when T is 0, S is 480. So we're going to go out 480, which would be about right there, like 4.8. And so our graph looks like this. And it actually can't extend beyond that for the sake of the problem, because then we would have either a negative amount of sweatshirts sold or a negative amount of t-shirts sold, which doesn't make any sense. So that's actually what the whole graph would look like. And it says list 3 different amounts of sweatshirts and t-shirts the band can sell to reach their goal. So you can just plug in different amounts for S and different amounts for T and figure out what S would be. You can also get it from the graph, but it's a little hard to get it from this graph because of the scale. All right, that is it.